All right, we're back here in active physics. The next unit you'll be covering is actually Home 2, back to the home book. And one thing to note is that Home Chapter 2 in the old edition is very similar to Chapter 6 in the new active physics, the new edition. So if you are working with the new edition or you get a hold of one, you should note that they are very similar. There is some differences in the new edition. A few activities are different. Some reading and content has been added, but is very similar. But we're going to continue looking at the older edition as many schools are still using it. So Home Chapter 2, Electricity for Everyone. And we'll be looking at the first few lessons in this video. So the challenge, basically, they made the universal dwelling in Home Chapter 1. Now they're presented with a challenge thinking about how to add electricity to these universal dwellings. What type of appliances would be absolutely necessary and can be powered by a wind generator that can only output so much electrical energy, and also coming up with a user manual to explain the concepts of electricity for those that will use this universal dwelling. And so that's where they're going to get the content. As you could see from our pacing guide here, these standards, if you look up in the Massachusetts standards, are the standards that deal with electricity. So this unit is all about electricity. And we're going to look at the first lesson now, 2.1, generate electricity, where they give you a period to do the activity and then some direct instruction. So I'll talk about what you really should focus on in the direct instruction. So let's take a look at 2.1, generate. It's called generate because they'll be using a hand generator to make a complete circuit. That's what they have to come up with. How can they make the light bulb? Some students remember this from middle school, are very quick at it. Others are not. So you'll definitely get some collaboration of students playing off one another, helping each other. It's a real nice way to open it. I also like that batteries available. As you can see, the circuit hooked up to a battery, to have students have the option of using a battery as well. And there's some use of steel wool in this 2.1 lesson where they will be hooking steel wool up to the generator, and we'll talk about what we could discuss as the current goes through the steel wool with students as we get to some of the direct instruction. So here's the things you want to focus on during that direct instruction piece. The two requirements for a working circuit, these are the basic requirements, have to be met. You need a source of energy, which would be the generator they're using or the battery. And I like to have students use multiple batteries and see how increasing the energy output would affect the brightness or the number of bulbs they actually could light up. That's something they need to know. And the other requirement, closed circuit, very important to know the circuit had to be closed. Students will notice this when they first make the circuit. If there's any breaks or openings, the bulb does not light up. This is a good time to introduce circuit symbols and circuit diagrams. They're going to get more of this in lesson 2.4, as you'll see in the video that covers that. But take a look at what the MCAS uses for circuit symbols, because there's a lot of different symbols used, like for a resistor or a bulb, that are slightly different from each other. So you want to match up the ones that are going to be the ones students see on the test to get them familiar with those. So introduce that briefly. They'll do more detail with that in 2.4. But insulators and conductors, a good time to talk about that is during this lesson. And I often like to have a few items like a penny, pencil, paper clip, rubber band, so on and so forth, that students can hook up to their circuit and see if the bulb will still work, and talk about what an insulator and conductor is. And define these terms they're going to be using throughout this unit of voltage, current, resistance. And then you could talk about that steel wool activity they did and a light bulb as a resistor and how that works, and compare that with what they saw in the steel wool when that produced heat and possibly some light. Maybe even touch a 9-volt battery to the steel wool and see what happens if you have a safe environment to do that. But it's pretty interesting. So that is what's going to happen. Now, in the PhET, again, loving these PhET simulations. You've seen them in some of my other videos. This is a really nice simulation where students can build circuits, so they get the hands-on with the lab materials from the active physics kit. But also, if you have computers available, they can also continue building circuits and actually get to see the flow of electrons through a circuit, some visuals you cannot see in the macro world when they're doing it with their their hands, but in a simulation they can. So they actually have some cool insulator and conductor piece to the simulation where they could put different components and see if it lights up still, build their own circuits. So definitely worth checking out the PhET simulation. There's a lot of lessons under this particular simulation that you can use with your students. So highly recommend that. 2.2, lighten up. So this, as you can see, is all about series and parallel circuits. Sometimes it's a bit tricky for students to hook up the parallel circuit. You may need to help them with that. But this is all about having them be able to recognize a series versus parallel circuit, what they look like, and the differences in them. And basically, they should notice the difference in brightness of the bulbs and what happens if you take one bulb out in a series versus a parallel and what's going to happen. And some key things they'll notice is series, like the old-fashioned Christmas lights. If one bulb goes out, they're all going to go out, versus parallel, where there's more than one path. So, if one path's closed down, the other path still works. And, like if they're trying to get to school and the road's closed, but there's another road to get to. And then talk about the differences in how voltage and current would work in a series and parallel circuit. So some key things students need to know in this lesson. The Physics Classroom, again, that wonderful website, has a really interesting analogy talking about the flow of current as cars going through a toll gate. The toll gate being the resistors, whether it's a bulb or just a regular resistor. You could kind of use this analogy, have students look at this and discuss and talk about this, and this will give them a better understanding of the difference in what happens in series versus parallel circuits when current flows through the resistors. So a nice little way to explain that for students. Check that out. And of course, back to PhET, take another day to have students use the PhET simulation and build series and parallel circuits. And what's really nice is the PhET has this ammeter and voltmeters you can hook up to the circuit and actually, get readings of what's happening to voltage and current and the difference between these two circuits. So highly recommend you check that out with your students. Then 2.3, the last lesson we'll discuss in this video, is all about Ohm's law and electrical power. So these formulas, you can see this actually came from the PhET simulation. They have a nice simulation about Ohm's law. Check it out. But students need to know this formula is on their formula sheet. And the formula for power, P equals IV, on the formula sheet. They should note there's two different power formulas on the formula sheet. They use one for mechanical power when they did it in the sports curriculum. Now this is about electrical power, so you might want to talk about that with students, which formula they need to use for which situation. And they need to know how to manipulate and change these formulas around. So if the algebra is a little bit weak, you can introduce the formula triangles and show them how to use that. But definitely give them lots and lots of practice with using these formulas, lots and lots of practice problems in this particular part of the curriculum, this lesson. So definitely take a day or two just for practicing these types of problems for students and talking about the relationships shown in these formulas. And this is a great simulation for showing how changing these variables affects the other variables. So once again, PhET, another wonderful visual, hands-on way students could start to understand Ohm's law. And in the next video, we'll talk about the next few lessons in this unit.